Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to start with the chapter number 8, that is exceptional control flow. In the yesterday's class I have finished with the chapter number 7, that is chapter that is linking. Now I'm going to start with your new chapter, that is chapter number 8, that is exceptional control flow. This chapter contains 8 topics, but prior to this, let's take a quick review what we have covered in the last class. That is the last topic that we have covered in the Friday's class. So let's take a quick review. In the last class, we have discussed about the linking, chapter number 7. Chapter number 7, linking continued. The topic is linking and the libraries. That is the linkers and the libraries, how linkers are maintained and how linkers are stored, and what are the types of libraries that is available in the linking. These are the topics that we have discussed in the last class. That is, first of all, there is an introduction about the linking. Then there is a control flow. That is, what is the control flow and how it will be managed. Then there is a static linking and the dynamic linking. We have discussed about the static linking libraries and the dynamic linking libraries. Then how to build the dynamic linking and how to build the static linking libraries. Then at last, Windows platform approach. That is how this approach will be followed on the Windows platform. So this is a library we have discussed. So library is a collection of sub-programs. That is, the predefined program that is available is stored in the library. So library is a collection of sub-programs used to develop the software. So it is a collection of the sub-program, that is the parts of the program that is used to develop the program or to develop the software. This allows code and data to be reused, shared, and changed in a modular fashion. That is, it allows the code and the data, that is, code means coding part, that is the programming coding, and the data part to be reused, shared, and the changed in a modular fashion. Modular fashion means in a module wise. Then linking, a linker resolves the reference between the executable and the library. So it acts as a mediator that resolves the reference, or that acts as a mediator between the executable and the libraries. Then we will discuss why we are using the libraries, means what are the benefits of the libraries. The benefits of libraries are from the software engineering point of view and from the system utilization perspective. So there are two perspectives that is used why we are using, or what are the benefits of libraries or using libraries. So first one is from the point of view the software engineering. Why? Because it increases the reusability, or it is easy to upgrade, that is, changes are very easy in the libraries. Then system utilization perspective, that is, we can utilize the system again and again if you are using the library. Suppose if I am using the library that is printf, so I can use the printf in one of them or one or more two programs. That is a reusability, and we can share the data at the runtime. Then we will discuss what is naming and what is binding. That is name binding, how we can bind the different names, or how we can bind the name in the system programming. This contains modules and the library routines, and determine the addresses at the runtime. Then we would also discuss about the print shared library dependencies. That is how the different libraries are dependent on the one another. That is, sub-programs are divided into one another. These are the categories of the libraries. These are the types of libraries. One is static linking libraries, one is dynamic linking library. So generally there are two types of libraries, static linking and dynamic linking. And dynamic linking contains two parts, that is runtime environment and programming language library. So these are the categories of library that we have discussed. This is the diagram that we have discussed. There are multiple tools, there are multiple options that is available. One is preprocessor, then compiler, then assembler, then linker, then loader. These are the resources, or these are the tools, module that is available from the source to the destination. That is, it starts with the preprocessor, then goes to the compiler, then goes to the assembly code, then goes to the assembler, linker, and then it goes to the loader. And this is the static linking library code. That is, what are the pros and what are the cons, means what are the advantages and what are the disadvantages of using the static linking libraries. Then we have discussed about the dynamic linking libraries. So these are the categories that we have discussed one by one, and we will also discuss about the pros and the cons, that is the advantages and the disadvantages of the static and the dynamic linking libraries. And this is the dynamic linking libraries. Then location of the library, that is, what is the location of library, where the library will be stored. That is, it will be stored either at the Unix platform, that is, we can either, or computer will either use the operating system, that is Unix. So if the library is stored in the Unix, so it is available in the Unix platform, and it is also stored in the Windows platform. For example, if I'm using the, or I'm writing the C program or C++ program, so I can run the code, because that contains library, as we all know, that contains some programs library. So that also must contain, or that also the code, the same code must also be shared or must also be executed in the Unix platform as well as the Windows platform. Then we also discuss how to link with the C runtime libraries, that is, how to run with the C runtime libraries. That is, if I'm writing the C program, how I can link the libraries, or how I can link the different programs, some program with the C at the runtime. That is divided into two parts, that is static and the dynamic linking. And it consumes 5154 218 bytes. This is the end of the introduction that we have discussed. Then we have discussed in detail what is static linking library, that is used to build, and the usage, that is how to build the static linking and what is the use of the static linking libraries. Then we also discuss about the GNU binary utilities. That is, what is GNU and what are the binary utilities available in the GNU. That contains strings. So these are the utilities that is available in GNU. One is strings, then AR, then NM, then size, then read ELF, then object dump. So these are the categories, these are the utilities that is available for the GNU binary numbers. Then we will discuss about the Unix layout format. So these are the format that is available of the Unix layout. So this is the example of the executable file, relocatable file that we have discussed, that contains multiple parts, that is header section, data section, header, data section, header section, text section, text relocation, symbol table, and etc. Then we will discuss in detail what is ELF, that is executable and linking format. This is one of the important topic, that is how ELF should be used and how ELF should maintain the code. That is your executable and linking format. Now these are the views of the ELF. From two views we can view, that is the two views of an ELF file. One is your linkable section, that is used with the link section. One is used with the executable section. So we have discussed about these two, how we can use the link section and how we can use the execution section. That is, there are two views, one is linkable view, one is executable view. Then we will discuss about the ELF section, that is what is contained in the ELF. That contains multiple parts, multiple extensions, that is .text, .data, .bss, .init, and .finet, .symbol table. These are the examples that we have discussed. Then we have discussed in detail what is dynamic libraries, what is dynamic linking, and how it will be used. Then we have discussed about the dynamic linking library example. So these are the examples that is available. Then we have discussed about the PIC, that is position independent or position independent code. These are the examples. This is the diagrammatical representation of the PIC. Then we also discuss about the GOT, that is global offset table. This is a table that is used to or PIC call functions, or that is used when PIC calls the function and operate on the data variables. Then we also discuss about the PLT, that is procedure linkable or procedure linkage table. This is the example that is discussed. Then dynamic linking libraries, what is how it is built and what is the use of the dynamic linking. Then GCC, that is GNU compiler collection. Then we would also discuss about the methods or the program that is used from the source to the destination. This is a diagrammatical representation. That's all for today's session. Now let's start with the new session, that is today. That's all for the yesterday's session. So now let's start with a new session, that is the today's session. The today's topic is chapter number 8, that is starting of chapter number 8, that is exceptional control. Exceptional control flow, that is means how to control the flow of the exceptions. Now what is an exception? It's a name advice. First of all, let's see the meaning of the word by word. Exceptional control flow, that is exceptions, that is any item or anything that is beyond the reach of the program, that is the exception. For example, if I'm declaring the variable or if I'm declaring the array, that is A5. This is the best example. Please listen carefully. If I am declaring the variable that is A5, that is the array A5, as I told you, it starts with the 0 and ends with the 4. That is, it contains the item at the 0 location, 1 location, 2 location, 3 location, 4th location, right? So it starts from the 0 and ending with the 4 because the maximum size is 5. If I'm going to access the item number 6, that is A6. So this is the exception. This is the exceptional array. Why this is the exceptional array? Because the limit of the array is A5, that is from 0 to the 4, and I'm going to access, and I'm using the computer, I'm using the C program to access the 6th element. That cannot be possible because the maximum limit is 5. This is an exception. So exception means that is beyond the program, beyond the reach of the program, beyond the reach of the user. That is known as an exception. So that is not in my hand, that is not in the hand of the computer. That is any unexceptional thing, that is the exception. Then control, that is how to control. Then flow, that is the flow of the exceptions or any flow or any dynamic nature thing. So if I combine three things, that is exceptional control flow, that is how to control the exception or how to flow the control of the exception. That is, if the exceptions are going down in a flow, how to control them. Sorry. This contains 8 topics generally. One is exceptions, that is the definition of exceptions, categories of exceptions, usage of exceptions. So that is the exceptions. Then second one is your processes. That is, what is a process, what are the types of processes, what is PCB, that is process control block. Then next is your system call, error handling. First of all, this chapter contains system call. What is a system call? Then how to use or how to handle the errors in the system call. Then next is your process control, that is how to control the process, that is again the PCB. Then signals, what are the types of signals and how signals are generated in the C program. Then non-local jump, that is how to jump or how we are jumping in the C language, that is the non-local, that is beyond the block, beyond the limit or beyond the size. We can jumping or we can jump the program by using the loop, that is a non-local loop or non-local jump. Then next is your tools for manipulating the processes, that is what are the tools or how many tools are available to manipulate the process, that is PCB, that is PIB. Then at last summary. So these are the 8 topics that is covered in this chapter. So let's start with the introduction of the ECB. That is, what is the ECF? Not ECB, it is ECF, that is exceptional control flow. This says from the time you first apply power to a processor until the time you shut it off. That is, from the time beginning when you start your computer, that is, give the power to the processor, until the time you are shutting the computer, the program encounter assumes a sequence of values. That is, the program contains a multiple value sequence of values, that is starting from A0, A1 till AN minus 1, where AK is the address of the corresponding instruction, IK. Each transition is from AK to AK1 is known as the control flow. That is, where AK is the address of the instruction, or where AK, for example, AK, in this there is AK, that is the address of the instruction, that is IK. Each instruction or transition from AK to AK1 plus is known as the control flow. So if I'm using the variable, and if that variable is going from one place to another, that is known as the control flow. A sequence of such control transfers is known as the flow of the control. That is, suppose if there are some sequence of such the control transfer or such transfer of control, that is known as the flow of the control or control flow of the processor. So if I am using the sequence, that is the control of the sequence of the control, that is this is the first control, second control, third control. So control transfer sequence is known as the flow of the control or control transfer of the processor, because I'm using the processor things, that is, I'm using the control flow of the processor, that is the CPU. That's why it's known as the control flow or flow of the control. The simplest method or simplest kind of control flow is a smooth sequence where IK and the IK plus 1 are adjacent in the memory. This is the simple flow or the simplest flow control start with the or is a smooth sequence. Smooth sequence means starting from IK, then IK plus 1, that is the adjacent in the memory, that is one after the another. Then typically abrupt changes to this control flow, that is if there is a huge change, that is the abrupt change to this smooth flow, where IK plus 1 is not adjacent to the IK. That is, they are not stored in the sequence way, are caused by the familiar program instructions such as jump, calls, and the returns. Such instructions are necessary mechanisms that allows program to react to changes in internal program state represented by the program variable. So this paragraph shows the, or this paragraph gives the detailed explanation, that is what is the flow or and how we can so sorry, that is how we can maintain the smooth sequence of the flow. That is a smooth sequence that reacts for the program, internal program by the variables. But systems must also be able to react to change in system state that are not captured by the internal memory variables and not necessarily related to the execution of the program. So these paragraphs says there is no sequence, there is no flow. So modern systems react to these situations by making abrupt change in the control flow. That is, to avoid these changes or to avoid these mechanisms, that is the limitations of the mechanism, limitations of the control flow, modern system introduce a new situation or the new method that is known as the ECF, that is exceptional control flow. So in general, we refer to the abrupt changes as the exceptional control flow. This occurs at all levels of a computer system. All levels means that is available at the CPU, CU, ALU, memory, at all the levels. For example, at the hardware level, that is at the CPU or the CU, event detected by the hardware trigger abrupt control transfer to the exceptional handler. That is, if there is at the hardware level, if any error or the event detected by the trigger means method that is used to detect the error, that is the trigger. So if any error trigger or event trigger by the or detected by the hardware trigger, then it must be passed or the control must be transferred to the event handler. So there is one exceptional handler or the event handler that is used to capture or that is used to handle the exceptions. So hardware trigger must control the transfer to the or must adapt or transfer the control to the exceptional handler. At the operating system level, the kernel transfer control from one user to the another user via context switching. At the application level, a process can send a signal to another process that adaptively transfer the control of a signal. That is the control that is the control is transferred from one place to another for transferring the control. For example, transferring the control to the exceptional handler. So a computer can transfer the control by using the exceptional handler, by using the signal, any method it can use. So why computer is passing the control or transferring the control, so that error can be detected and used by the exceptional handler. As programmers, there are a number of reasons why it is important to understand the ECF. So these are the features or these are the benefits why we are using or why we are accessing or why we are able to understand the ECF, or what is the benefit of understanding the ECF. So first point is understanding ECF will help you understand important system concept. That is, if I have a knowledge of the ECF, I am able to understand important system concept. Why? Because ECF is the basic concept or the basic mechanism that operating system should follow. So if I have a knowledge of the ECF, I should have an important knowledge, or I should have a system concept knowledge. That is the important system concept knowledge. This is ECF is the best mechanism that operating system uses to implement input-output processes and virtual memory. Before you can really understand these important ideas, you need to understand the ECF. That is, if you are able to understand these ideas, these concepts, then you must be able to understand the ECF. Then next is understanding the ECF will help you understand how application interact with the operating system. So first point is if you have a knowledge of the ECF, you are able to understand the important system concept. In the same way, if you have a knowledge of the ECF, you will be able to understand the how application or what is the role of the operating system. That is how application interact with the operating system. This says applications request services from the operating system by using a form of ECF known as the trap or the system call. That is, application request for the services. As we all know, applications like application software like Word, Excel, PowerPoint, they need a software, they need an operating system. So they request for the operating system in the form of system call or the trap. So this point says application requests services from the operating system by using a form of ECF known as the trap of the or the system code. So these are the requests that is provided by the application to the operating system in the form of trap or the system code. Then next point says understanding ECF. Understanding ECF will help you write interesting new application program. That is, if you have a knowledge of the ECF, that is how to control the flow or how to flow the exception control or the how to control the exception flow, that helps you to write interesting new application program. That is, if you have a knowledge of the ECF, you are able to understand, you are able to give the interesting ideas about the application programs. That is, you have a mechanism for creating the new processes, waiting for the process to terminate, notifying other processes of the events, and detecting and responding to these events. So you are able to understand these concepts, that is what is the process, how we are dealing with the process, and what is the more than one systems or more than one processes are waiting for one another. Next point says, understanding ECF will help you understand concurrency. That is, if you have a knowledge of the ECF, you are able to understand the concurrency. As a name advice, concurrency, that is more than one. So you are able to understand, that is, you are help you to understand the concurrency. This says ECF is a basic mechanism for implementing the concurrency in a computer system. An exceptional handler, this is the most important point, that handles the exception, that is known as the exceptional handler. That is, exceptional handler that interrupt the execution of an application program, processes and threads whose execution overlap in time, and a signal handler that interrupt the execution of an application program are examples of the concurrency. That is if there are more than one process, there are more than one thread whose execution overlap in time, that is more than one process are executing at the same time, that is concurrency. That is avoided by, or that is you are able to understand the concurrency term when you have a knowledge of the ECF. Then next point says, understanding ECF will help you understand how software exception work. That is, if you have a knowledge of ECF, that is exceptional control flow, so there is so much obvious thing, that is, you have a knowledge of the exceptions, because without knowing the knowledge of the exceptions, you are not able to control the flow of the exception. So this also this will also gives you an idea of the exception, that is, what is the exception, what are the types of exceptions, why we are using the exceptions, and why exceptions are created by the system. So these are the benefits that is provided by the ECF. So if you have a knowledge of the ECF, you are able to understand, or you are able to think about the system, concurrency, material, software exceptions. So these are the benefits, or these are the features that is provided by the ECF. Up to this point in your study of system, you will learn how application interact with the hardware. So till this point you are able to understand, that is how application interact with the operating system, that is your hardware. This chapter is a pivot table, or pivotal in the sense that you will begin to understand how application interact with the operating system. Interestingly, these instructions will revolve around the ECF. We describe the various forms of ECF that exist at all the levels. So this chapter contains all the levels of the ECF, full form of ECF, why we are using the ECF. Now, let's start with the first topic, that is exceptions. That is, what is the exceptions, why we are using, or why a computer gives the exception. This says an exception is a form of, or exceptions are a form of, that is, more than one exceptions are available or created. That is, exceptions are a form of exceptional control flow. That is, it is a category of the exceptional control flow, that is ECF, that are implemented partly by the hardware and partly by the operating system. So these are implemented, or exceptions are implemented partly by the operating system and partly by the hardware. So some part is going to the hardware and some part is going to the operating system, or implemented by the operating system. That is known as the exception. So these are a form of, or these are a category of the ECF, that is exceptional control flow. Because they are partly implemented in hardware, the details vary from the system to system. That is, different system have a different system hardware configuration, another system have another hardware configuration. So they are dependent on the system to the system, that is, exceptions are dependent on the system to the system. However, the basic idea is same for every system. So next point says, an exception is an abrupt change in the change flow in response to some change in the processor state. This is one of the important definition. This says exception is an abrupt change. Abrupt change means a drastic change. So it is an abrupt change in the control flow if there is a flow, control flow, that is that are smoothly going from one place to another place to another place to another. And if there is any drastic change in between in response to the change in the processor state, there are multiple states of processor, that is ready state, running state, killing state, suspending state. So if a processor or the CPU state is different or differs, that is if a CPU state is converted from ready to the running, and in the meantime there will be a control flow, or there will be a drastic change in the control flow, that is known as the exception. That is, first of all, understand there is a processor state, that is a ready, running, wait, suspended. So if there is a change in the processor state, that is a processor is converted from the ready to the running to the suspended, at that time if there is a drastic change in the control flow, that is known as the exception. Figure 1 shows the basic idea. In the figure, the processor is executing some instruction, that is a current instruction, that is I current, where when a significant change in the processor state occurs, that is or the computer is executing the current instruction when the processor state differs, or when the processor state change from one part to the another part. The state is encoded as various bits and signal inside the processor. The change in the state, that is if a processor changes the state, that is converted from ready to running to suspended, that is known as the event. The event might be directly related to the execution of the current instruction. So this is the example, this is the diagram, that is anatomy of exception, that is what is the exception. So this is this is the application program, this is a exception, that is the exception processing, this is the exception handler. There is an exception, there is an exception return. So this is the exception that is going to the exception processing, that process the exception, then it is returned to the exception, that is the application program. This is the application program. Suppose my word is running smoothly, my MS Word, that is the application program. If there is some error came place, that is an exception. So this shows there is a break in the line that gives the exception. Then that exception is handled by the exceptional processing or given to the exceptional processing. Then after doing the processing, this will give the back to the, or this will give the result back to the application program, that is the exception return. That is also optional. This is not mandatory that every exception is returned to the application program. There are some exceptions which are not returned by the returned to the application program. Why? The main reason is that, the main concern is that exceptions are not handled, or that exceptions are not related to the application program, or they are not rectified by the exception processing. Then this is the I current, that is the instruction current. This is the instruction next, that is executed by the application program. This says event occurs here. So event occurs at the current instruction, that is the I current. So there is application program, there is exception, there is exception return, there is a processing, there is exception handler, there is a event occurs here, that is the event occurs at the I current, that is the instruction at the current position. This says a change in the processor state, that is the event, triggers an abrupt control flow. That is, there is a change in the processor state. This is the processor state that changed from the current to the next. That is control that passes the control from the application program to the exceptional handler. After it finish processing, that is after it finish processing, the handler either return control to the interrupt program or the abort. That is either it finishes the exception, or either it finishes the program at this level only, or either it return to the application program. In any case, when the processor detects that the event has occurred, it makes an indirect procedure call, that is the exception. So when a CPU detects that there is an event or that the event has occurred, it makes an indirect or it gives an indirect procedure call, that is an exception, through a jump table known as the exception table. So this is a table that is known as the exception table, that is also known as the jump table, that provided to the operating system subroutine, or that is provided to an operating system subroutine, that is the exception handler, that is specifically designed to process this particular kind of event. So this says there is an exception table that is used, or that is used by the operating system as an exception handler, that is used to, or that is designed to process the event. When an exception handler finishes processing, one of the three things happens depending on the type of event that caused the exception. So what are the types of event that is caused, or that is, or what are the three things that is used, or depending on the, or what are the three things that is happened depending on the type of event that caused the exceptions. The handler return control to the current instruction. That is, there is an event handler that returns the control, to the, or that returns the control to the current instruction that is executing, that is I current, the instruction that was executing when the event occurred. So this control, or this return the control to the current instruction, the instruction that was executing when the event occurred. Suppose there is an event occurred, so suppose there is a error occur, that is the event occur, so control is passed to the exception processing. Or control is transferred to the exception handler. So there is a processing takes place that that do the processing by the, or that does the processing by the exceptional handler or exception processing. So it revert back to the that current condition, that current execution, that current instruction that is provided by the or that is currently executing by the operating system. Next thing that is common in every event, depending on the event to event, the handler returns control to the I next. So first of all, it goes to the I current, then handler also returns the control to the I next, the instruction that will be executed next after the next had the execution note occurred. That is, first of all, the exception handler, exception processing, gives the process or handles or return the instruction to the I current, then it is converted or it is transferred to the I next. The handler abort the interrupted program. So if there is any more than one error, there is no rectification of the error, so handler return adopt the abort. The abort means finishes the interrupt program. Now next is your exception handling. So these are the exceptions. Now let's see what are the content, or what is the content that is available in PPT, and the next one is exception handling. So let's start with the help of PPT, that is chapter number 8, exceptional control flow. So first of all, what is a control flow? As I told you, from starting to the shut down, that is from startup to the shutdown, a CPU simply reads and executes. Executes means interrupt a sequence of instructions one at a time. The sequence, or this sequence, is the system physical control flow, or the flow of the control. That is the sequence that is maintained from the starting up, that is from the starting of the system until the ending about the system, that is known as the control flow. This is a control flow. It start, this is the time, it start at the startup, then instruction 1, instruction 2, instruction 3 till instruction end, and there is a shutdown. So start with the startup, and then multiple instructions are executed, then at last shut down the program or shut down the module. Then next slide is altering the control flow. That is how to alter the control flow. Up to now, two mechanisms for changing the control flow. That is, two mechanisms are used in the program for changing the control flow. That is the jump and the branches. Jump means jumping from one location to another location, and branching means dividing the same program into the multiple parts. That is known as the jumping. Then next mechanism is call and return using the stack discipline. So use the stack, that is the LIFO method, last in first out in this, that is to alter the control flow. See, so these are the two mechanisms for changing the or for altering the control flow. Both react to the changes in the program state. That is, both react or both approaches to the changes, or both changes are reacted or approached in the program state. Then next point says how to alter. It is inefficient for a useful system. That is, altering is not useful, or it is not sufficient for a useful system. Why? Because it is very difficult for the CPU to react to the changes. Because if I have knowledge of the CPU, I have knowledge of the one CPU, but in CPU there are multiple parts. So it is very difficult for the CPU to react to the changes in the system state. Data arrives from a disk or the network adapter. Instruction divided by or divides by 0. Uses hits or user hits control C at the keyboard. System timer XY. So these are the multiple methods. Why why it is very difficult for the CPU to do the changes. Suppose I am doing the changes, but the system clock is not responding, or the system clock, or there is an error in the system timing or system timer. There is a timer that is available in the system that expires. So that is not, or that is for this, that is very difficult for the CPU to react to the changes in the system state. For this purpose, system needs mechanism for system exceptional control flow. That is, system needs a mechanism, system needs a method, that is the exceptional control flow, that is your ECF. Now, what is the ECF? That is a mechanism for the exceptional control flow. So this is a mechanism, this is a method that is used for the exceptional control flow that exists at any level or all the level of a computer system. So if there is any exception occur, or if there is any error occur, if there is any adapt occur, that is controlled by the exception control flow, because it is available at all level of the computers. Then it is used as the low level mechanism, and it is used at the high level mechanism. How it will be used at the low level mechanism? There is a exceptions. So it is used in the low level mechanism as a exceptions combination of the hardware and the software. What is the exception? That is change in the control flow in response to a system event. That is a exception, that is change in the system state. Then next is your high level mechanism. So one of the categories of the ECF is your low level mechanism. The next one is your high level mechanism that contains multiple multiple methods, multiple mechanism. That is process control, process context switch, that is your PCS. Then signals, then local non-local jump, that is set jump, long jump, then implemented by either. So this high level jumping is, or high level mechanism is implemented by either using the OS software, that is your context switch and signals, or either using the C language runtime libraries. So these are the exception control flow mechanism, that is the low level mechanism and the high level mechanism. Then next is your syntax error, runtime error, and the logic error. So there are three kinds of error that is available: syntax, runtime, and the logic error. Syntax error arises because the rule of our language has not been followed. Suppose in C language there is a rule that for writing any line on the screen, that is for displaying any output, we have to write printf. So this is a mandatory condition. If I'm not following the syntax, if I'm not following the criteria that is set for the C language, that gives an error. So that is a system error, because the rules of the language has not been followed. They are detected by the compiler. In the same way, runtime error are the error that occurs when the program is running. Suppose a program is running, and at the time of running the program there is an error, or there is an difficulty in executing the program. That is an error. There is a semicolon missing, bracket missing. So that error, or that type of error is known as the runtime error. Next point says, if the environment detects an operation that is impossible to carry out. Logical error, that is the next error, that is a logical error occurs when the program does not perform the way it was intended to. So this is the logical error. There is a logic. Suppose I am giving the logic that this program will run from starting to the end by dividing the program into some module. That is my logic of the error. But if the program is not executed in the same way, is not performed in the same way it was intended, that is known as a logical error. So there are three kinds of error: syntax error, runtime error, and the logical error. If I'm not following the sequence syntax, that is known as the syntax error. If I'm not following the rules regulation at the runtime, or if any error is available at the runtime, that is known as the runtime error. Then logical error means if there is a change in the logic, if there is a change in the structure of the program, that is your logical errors. This is an example of the runtime error. This is the error if an exception occurs on this line, the rest of the lines in the method are skipped and the program is terminated. Why? Because it is available at the runtime error. This is the output, this is terminated. It will not execute it because there is an exception, there is a runtime error in this line. Then catch runtime error. How to catch? By using the syntax that is the try and the catch. So I'm using the try, that is try this part, this is the error, try this, that is int number equals to scanner dot next int function. So first of all there is a try, that is try the method, then catch, it will catch the method, that is the input mismatch exception here. This is the explanation of the catch method. Then these are the exception classes, that are the categories of the exceptions. And this is the object, throwable, exceptions, errors, class not found exception, input output exception. That is, a class is not found in the C++ program. Suppose I am writing the C++ program. So there is a one condition, there is a one method that is used at the starting of the C++ program, that is a class. Suppose I forgot to write the class in the C++ program. So that is the error, or that is the exception, that is known as the class not found exception. In the same way, if there is any error in the giving the output, or in giving the input and taking the output, so that is known as the input output exception. In the same way, there is a AWT exception, runtime exception, several more classes of the exception. In the same way, if there is any error, so that error may be a linkage error, virtual machine error, AWT error, several more classes. And the runtime exception sorry, and the runtime exception is generally available, or generally error is available on the arithmetic expressions, null pointer exceptions, in index out of bound, that is array is reaching out of bound, illegal argument, that is I'm declaring the argument but I'm not giving the semicolon, that is an illegal argument, several more classes of exception classes. Then these are the system errors. System errors are thrown by the JVM, that is Java Virtual Machine, and are represented in the error class. So this is the error class. These are the system error that is provided by the, or thrown by the JVM. Then these are the error or the exception that describe the error caused by your program and the external circumstances. So these are the exceptions that is provided by the, or that is available for the program, and the circumstances that is available for the external environment. Then next is your runtime exception. So this is a runtime exception that is caused by the programming errors such as bad casting, accessing an array out of bound, or and numeric errors. Then checked exceptions and the unchecked exceptions. That is what is the checked exceptions and what is the unchecked exception. So this says runtime exception, error and their subclasses are known as the unchecked exception. That is the runtime error or is simple error, and their subclasses are known as the unchecked error. All the other exceptions, that is known as the checked exceptions. Then what is the unchecked exceptions? That reflects the programming logic error. So if there is a error in the logic of the program that is not recoverable, that is not rectified, that is known as the unchecked error. So there are multiple unchecked exceptions that is available. One is null pointer exception, one is index out of bound. Suppose I'm declaring the array as an A5, and if I'm accessing the arrayment that is A6, that is array out of the bound, that is reach out of the reach of the array, that is known as the array out of bound exceptions. In the same way, if I'm using the pointer, but that pointer is a null pointer, that is I'm declaring the pointer as a zero value, that is a null pointer exception. So these are the categories of the unchecked exceptions. In the same way, these are the categories of the checked or the unchecked exceptions. These are the unchecked exceptions, that is arithmetic exception, null pointer exception, index out of bound, illegal argument exception, multiple categories of the exception that is known as the unchecked exceptions. This is how to declare, how to throw, and how to catch the exception. There is a catch exception. This is the method. This is a throw. This is the declare. So this is the declare, throw. This is the called expressions. Then how to declare the or how to define the exception. Every method must state the type of the checked exception it might throw. That is known as declaring the exception. This is the method how it will be declared. That is public void my method throws IO exception. Public void my method throws IO exception, other exception. Then how to throw the exception. This is the example, that is how to throw the exception. When the program detects an error, the program can create an instance of the appropriate exception type and throw it. So this is known as the throwing of the exception, and this is the syntax that is used, that is throw new the exception function. And these are the categories that we have discussed. This is the current, this is the next. This is the interrupt example. Next is your asynchronous exception. That is a category, another category of the exception. But before this, let's take a quick let's take a 5 to 10 minutes break. Then come back, then starting with the asynchronous exception. So let's take 5 to 10 minutes break. Now let's start with the next slide, that is asynchronous exceptions. So these are the categories of exceptions. That is, what are the categories of exceptions? That is asynchronous exception. That is also known as the interrupt. This is caused by event external to the processor. That is, there is any event, there is any error that is occurred that is external to the process. That is known as the interrupt or the asynchronous exceptions. So this is caused by the events external to the processor. This is indicated by setting the processor interrupt pin. That is, it is indicated. That is how we can detect that there is an external error or there is an interrupt that is occurred. It is indicated or it is detected by setting the processor interrupt pin. And the handler returns to the next statement. That is, the handler returns to the next statement. That is your interrupt. That is the asynchronous exception. These are the example that is used. That is input output interrupt, that is hard reset interrupt, soft reset interrupt. This is the examples of the interrupt that is also known as the asynchronous exceptions. Then next is your synchronous exceptions. These are caused by the event internally, that is occurs as a result of the executing an instruction. So for asynchronous, that is external to the processor. Simply synchronous, that is internal to the processor for executing the programs or as a result of executing the instructions. What are the traps, what are the faults, and what are the aborts? Traps are intentional. Example, system call, breakpoint traps, special instructions, returns control to the next statement. And what are the faults? That is unintentional. That is, faults are not intentional, that is unintentional but possibly recoverable. That is, we can recover the faults. Then next is your examples. What are the examples of faults? That is page fault, protection fault, floating point exceptions. Then what are the aborts? That is why there is a process that is abort, that is killing the process. That is unintentional and unrecoverable. Example, parity error, machine check, that aborts the current program. These are the synchronous exceptions that is used with the synchronous exception cases. Then this is the example, this is the trap example. This is the fault example 1. This is the example that you have to study. This is the array variable that is declared at the 1000. This is the 500 is initializing the value as a 13. This memory reference that user writes to the memory location. This is the second error, that is invalid memory reference that user writes to the memory location. Address is not valid. This is user writes that is not valid address. Then next is your processes, but that is the next part. So now this is the exception handling till this we have discussed. Then exceptional handling. This says exception can be difficult to understand. That is, it is very difficult to understand the exceptions because handling them involves close cooperation. But why there is a close cooperation? Because that involves a cooperation between the hardware and the software. So it is very difficult to detect an exception and handle them because they are very close. That needs a very close cooperation, or that involves a close cooperation between the hardware and the software. It is easy to get confused which component perform which task. So it is very difficult to accept the or handle the exception. Let's look at the division of the labor between the hardware and the software in more detail. This is the exception table example. The exception table is a jump table where entry k contains the address of the handler code for exception k. This is the exception table. This is the code for the exception handler, that is 0, 1, 2 till n-1. This is the exception table. Codes for 0 it is exception table, then code for the exception handler, then code for the exceptional handler 2, and this is the code for the exception handler n-1. These are the multiple codes that is available for the exception table. That is, this is the code for the 0, this is the code for 1, this is 2, this is for n-1. Each type of possible exception in system is assigned a non-unique, non-negative integer exception number. This is the number that is given, that is code handler for exception or handler 0. So each type is assigned, or each type of the possible exception is assigned a unique number, unique non-negative number. This is one of the important concept, one of the important thing to understand. Make a note of it, that it is assigned, or possible exception in a system is assigned a unique non-negative integer exception number, that is either 0, 1, 2, but that is not negative number. Some of these numbers are assigned by the designers of the processors. Other numbers that are assigned by the designer of the operating system, that includes kernel, that is the memory resident part, that is the internal part. Examples of the formal includes, formal means examples of the exception includes dividing by 0. Suppose I'm dividing any number by 0, that gives an error, that gives an event, that gives an exception. So this is the example of the exception. Page faults, this is also the example of the exception. Memory access violations, that is I'm accessing the memory beyond the bound, that is same example. If I'm declaring the array as a A5, I'm accessing the value of a A6, that is memory access violations. Breakpoints, this is also an exception. If I'm tagging the breakpoint, or I've created the breakpoint at level number 5, until level number 5 there is no error, and the error finds at the level number 6. So that is also a violation, that is also a break error exception that is available in the program. And the arithmetic overflow. Suppose I'm using the arithmetic 2 plus 3 minus 5. And it can overflow, it can give more than beyond the stack limit that is stored in the stack, that is known as the overflow. So these are the multiple exceptions that is available in the, or that is the types of the exceptions. These are the examples of the formal one. What are the formal one? That is designed by the processor, that are assigned by the designer of the processor, that is given by the manufacturer. Other, that is designed by the or designed for the operating system. That includes the system call and the signal from external input output devices. So these are the categories of the exception number. That is some are assigned by the by default by the manufacturer, and some are available by the or given by the system call or the operating system, that is a memory. At system time boot time, that is when the system is booting up, when the computer is reset or powered on, that is when the system is powered on, the operating system allocates and initializes a jump table. So when a computer starts up, the operating system automatically initializes the operating system allocates and initializes a jump table. That is a jump table, that is a code for the exception handler exception table, so that entry of k or the k entry k contains the address of the handler for exception k. So there is an entry for the k that contains the address of the handler for the exception k. Figure 2 shows the format of an exception table. This is the figure 1, or this is the figure 2 that shows the exception of the or that show the format of the exception table. That is the exception table, that is code for exception handler 0, 1, 2 till n minus 1. At runtime, so this is first paragraph is said at the system boot time, that is when the system is booting up, that is when the system is starting up, and when the system is running up, that is at runtime. So at runtime, that is when the system is executing some programs, the processor detects that an event has occurred. So processor, that is the CPU, detects that an event has occurred and determine the corresponding exception number k. That is, at the time of executing, if the processor detects that an event has occurred, that is the error has occurred, and determine the corresponding exception number k, the process then triggers the exception by making an indirect procedure call to entry number k of the exception table. So this is a table that contains a code for the exception handler. Suppose I'm executing the program, same example, and the error occur or the event occur at processor number 7, and then number 7. So the system uses the code for the exception handler number 7, not code for the exception number 1. Why? Because there are multiple categories of the event, and the unique code is assigned for the each event. Suppose there is a one event, that is the event number 1, so separate code is used for the event number 1. If event number 2, separate code for the event number 2. Event 3, separate code for the exception handler 3. So there are unique code that is assigned to the exceptions table. So this is the same example. If there is a k entry of the exception table to the corresponding exception handler. So this is, if it is available at the k, it is going for the code for the exception handler k. The processor then triggers the exceptions by making an indirect procedure call through entry k of the exception table to the corresponding handler. As I told you, figure 3 shows how processor uses the execution table to form the address of the appropriate exception table. So this shows how it will generate the address. This is generating the address of the exception handler. The exception number is an index to the into the exception table. This is how to generate the exception. This is the exception number. What is the exception number? That is the index to the exception table. Suppose I'm using the exception number as a A0. So 0 is the index, that is the location where it is stored in the exception table. If I'm using E6, that is a location, that is the address where the exception or where the exception is stored in the exception table. If I'm using the E7, that is it is stored or the exception is stored at the memory address, that is the 8th memory address in the exception table. So it is stored at the 8th rank. So this is how to generate the address of the exception, or how to generate the address of the exception handler. So this is exception table base register, that is a base register. Base register means the index, then exception number, that is for example x4, address of the entry for the exception number k. So this is the address that is also coming for the exception number k. Then there is a plus, that is the addition of all the things, that is exception number as well as the exception table base register. Then it is going to the next level, that is 0, 1, 2, that is it is going to the next that is next level, that is the exception table. This is exception table starting from 0, 1, 2 until n minus 1. So this is the figure that shows how to generate the address of the exceptional handler. This says the exception number is the index into the exception table. So this is the number that is given, that is index into the exception table, whose starting address is contained in a special register, that is whose starting address is contained in the special CPU register, that is known as the exception table base register. So every address, that is every entry has a unique address that is stored in a separate table. That table is known as the exception table base register. This says an exception is akin to the procedure call, that is exception is available to the procedure call, but with some important differences, that is exception is different from the procedure call, almost similar, but there are few differences among them. So what are the differences between the procedure call and the exceptions? As with the procedure call, the processor pushes a return address. So if I'm using the procedure call, then the processor pushes the return address on the stack before branching to the handler. So if I'm declaring the variable, if I'm using at the procedure call, that is when the calling the procedure, then the processor pushes a return address on the stack before branching to the address. So first of all, it pushes a return address into the stack, that is inserting the return address into the stack before branching to the handler, that is before dealing with the before dealing at the execution phase, it pushes the return address to the stack field. However, depending on the class of exception, the return address is either the current instruction or current address. That is, it depends on the size, it depends on the class of the exception, that depends, it is either used as a current execution, it either used as the return address. Then the return and depending on the class of exception, the return address is either the current instruction, that is the instruction that was executing when the event occurred, that is your current instruction, or the next instruction. So address is available at the current instruction or the next instruction. Current instruction is that instruction which is available or which is when the event is occurred. Suppose the event has occurred at the 5th instruction, so my current instruction is 5th one. Suppose I'm using or I'm executing the instructions, if the event occurred at the 6th one, so that is my current instruction, and the next one is your for example, if I'm taking the example of 6, the next one, that is a 7, is the next instruction that would be executed after the current execution at the event not supported. That is the next instruction that is executing after executing the current instruction. Next point says the processor also pushes some additional processor states into the stack. So the processor also pushes, that is the CPU also pushes some additional processor, that is also insert some additional processor into the processor state. Processor state means either it is in running state, ready state, waiting state into the stack so that or that will be necessary to restart the interrupted program. So it also pushes some additional processor to restart the interrupted program when the handler returns. For example, IA32 system pushes the E flags register containing, among other things, the current condition code into the stack. So this is an example that it is using the IA32, that is Intel Architecture 32, pushes the E flags register containing, among other things, the current condition code onto the stack. Then next point says if the control is being transferred from a user program to the kernel, that is if the control is transferred from the user program to the kernel, all of the items are pushed into the kernel stack rather than on the user stack. So if the control is transferred from the one program or from the user program to the kernel program, so all the items are pushed on the kernel stack rather than on the user stack. So if the items are available in the kernel stack, it is stored in the kernel stack. Otherwise, it is stored in the user stack. Next point says exception handlers run in the kernel mode. That is, if there is an exception handler that runs only the kernel mode, not in the system mode, which means they have complete access to all the system resources. Once the hardware triggers the exception, that is once the hardware detects the exception, the rest of the work is done in the software by the exceptional handler. So the main role of first of all, as I said, it the main category or the main difficulty is that of detecting the exception is that it lies between, or it approaches between or control between the software and the hardware. So once the hardware triggers or detects the exception by using the table, by using the exception table, so then rest of the work, then another work, that is left work or the left of work, and the rest of the work is done in the software by the exceptional handler. So first of all, the hardware detects the error by using the, or detects the event by using the exceptional table, and then rest of the work, another work is also done in the software by the exceptional handler. After the handler had processed the event, that is once the handler processes the event, it optionally returns to the interrupt program by executing a special return from interrupt instruction. That is, if the handler has processed the event, it optionally returns to the interrupt program. It is a optional, that is, it may be returned, it may not be returned by executing a special return from interrupt instruction. This is the instruction that is used, that is a special instruction. So that instruction is known as the return from interrupt instruction, which pop up the appropriate state or state back into the processor. That is, it is the appropriate state that is available in the processor control and the data register that restores the state to the user mode. If the exception interrupt a user program and then return control to the interrupted program. This is this paragraph says once the role of the hardware is finished, then role of the software is started up. That is, then the software interrupted the or uses the handler, check the interrupt. If there is an interrupt that is suitable, that is rectified, then it gives the special return, that is the return from the interrupt instruction. Otherwise, it gives that there is no usage, that is the, it aborts the instruction, aborts the process, that is kill the process. Next is your classes of exceptions. This is a new topic that includes interrupt, traps, fault, aborts. But no time is left. It is 5:41 already. So let's finish over here only. In the next class, let's start with this topic, that is the classes of the instructions. Right. Now, if you have any doubts, then please text the doubt. But before that, let's take a quick review what we have covered in the today's class. That is so important according to me, because without knowing what is covered in the today's class, it is very difficult. In the today's class, we have started with the chapter number 8, that is the exceptional control flow. We will discuss about what is a control flow. That is any flow that is starting at the starting up of the computer and ends with the shutting down of the system, that is known as the control flow. or that sequence is known as the control flow. This is the example that is given. Startup, instruction 1, instruction 2, instruction 3 till instruction N. Then there is a shutdown. So this is the control flow, that is how the flow of the control should be maintained. Then how to alter the control flow, that is how to alter the control flow that is available in the program. This is up to now. We are using the two mechanisms, that is a jump and the call and the return. This is insufficient for the usual flow program. Then system needs a new mechanism that is known as the exceptional control flow. That is your ECF, that is the exception control flow, that are used in two mechanisms, that is low level mechanism and the high level mechanisms. Then we have discussed about the errors, different types of error, that is syntax error, runtime error and the logic error. So syntax error arises if there is any discrepancies between the rules of the language. Runtime errors if there is any problem in the runtime environment. And the logical errors, that is when the program does not perform the way it was intended, that is it is not as per the desired output, that is your logical errors. This is the example of the runtime errors. This is the examples of the runtime error, how it will be used or how it will be removed. That is done by using two methods, that is the try and the catch. This is the try block. So first of all, try means try the method, then catch, that is the passing the method to the next one. Then these are the exception classes. There are different classes, different types of exception, that is divided into exception classes. That is divided into exceptions, errors, object, throwable objects, multiple exceptions that is available at the system errors. So these are the system errors that is available or that is reported by the JVM, that is a Java virtual machine. This is your exceptions that is used. These are the errors that is described the program. Then these are the runtime errors that is available at the runtime, such as programming error, detecting out of the beyond. Then next is your we have studied about the difference between the checked exceptions and the unchecked exceptions. These are the categories of the checked as well as the unchecked exceptions. So runtime errors, any simple error and their subclasses are known as the unchecked exceptions, and the rest of the exceptions are known as the checked exceptions. These are the unchecked exceptions. In this case, unchecked exceptions reflect the programming logic error that are not recoverable. That is the error that is unchecked, that is not recoverable, that is known as the unchecked exceptions. The example includes null pointer exception and the index out of bound exception. That is, if I am declaring the pointer as a null, that is a null pointer exception, and index out of bound, that is beyond the array element. Then this is the category of the checked and the unchecked exceptions. Then we have discussed about the how to declare, how to throw, and how to cache the exceptions. This is used for the declaring the exception. This is the method, that is public void my method throw input output exception. Then how to throw the exception. This is the next method, that is how to throw the exceptions. Then we have also discussed what is the exception through the diagrammatical representation, that is so this is the exception, that is the current one, this is the current one, this is the next one. Then we have discussed about the interrupt vector. This is the interrupt vector, this is the exception table, that is the code for the exception handler 0, 1, 2 till n-1. Then we have discussed about the types of the exception, that is asynchronous exceptions and the synchronous exceptions. Asynchronous exceptions are known as the interrupt that are caused by the event that is external to the processor, that is outside of the processor. And the examples are the input output interrupts, that is a error that is occurred beyond the processor, that is if I'm using the input and the output interrupt. Hard reset interrupt, soft reset interrupt. Then next exception is your synchronous exceptions. That is the next category, that is synchronous exceptions, that is occur or that occurs as a result of the executing the instructions. That is internal to the instruction, that is your synchronous exceptions. Then what are the traps, what are the faults, and what are the aborts that is used in the synchronous exceptions. This is a trap example, that is how to open a file. Then this is the fault example number 1. This is the example number 2. This is what we have covered with the help of the slides. We have started with the chapter. We discussed about the various topics, like what are the various topics in this chapter. Then we have started with the exception control flow, some basics, what are the features of exception control flow. Then we also discussed what is the exception, why we are using the exception, that is the exceptions. What is the exception? This is a diagram that we have discussed, that is the anatomy of the exception. Then we have discussed about the exception handling, that is how to handle the exceptions. This is a diagram that shows the how to handle the exceptions. Then this is the method that is used to use the hardware as well as the software, that lies between the hardware and the software. So these are the points for the hardware, and then the rest of the work is done by the software. So this is what we have covered in the today's class. Now if you have any doubt, then please text the doubt and I will answer you. So that's all for today's session. In tomorrow's class, I will start with the next topic, that is the classes of the exceptions, and the next topic, that is the process. So these are the two topics that will be covered in the next class, classes of exceptions and the processes. So that's all for today's session. Thank you so much, everyone.